Hello friends, welcome to my channel. Today we'll discuss pattern matching, the match syntax, if let and while let. Now let's get started. So pattern matching is commonly used in conjunction of enum mostly, but we can apply pattern matching across many other variable type. For example, simple integer type, or character, string, struct and tuple and etc. So now let's see one example with the simple immutable variable x, which is data 5, and we'll try to apply pattern matching. So this is the match syntax. So match, and this is the variable or the expression. So if x equal to 1, we're trying to print 1. And if x is equal to, this is syntax for OR. If x is 2 or 3 or 4, then we'll print this message. And we can use in range as well. If x falls between 5 till 20, we'll print this message. Or anything else, this underscore is for other conditions which is not satisfied in any of this above. So then this message will be printed. In our case, x equal to 5, so it met in this criteria. So 5 to 20 is getting printed. In case if you change x to 50, then something else will be printed. If x we have like 4, then this condition will be satisfied and 2, 3, 4 will be printed. So match syntax seems sometimes a little bit verbose. We can have a simplified syntax into using if let condition as well. But prior to that, we'll see some other scenarios where we can use the match pattern matching as well. Then slowly we'll go to if let condition. Here we define tuple coordinates. Usually tuple, you are familiar with the two variable or two data, one this is first thing and second thing, but tuple doesn't restrict us to have the multiple different data types. In this case we have like 3 similar integer type, but you can mix and match as well. In this example, let's say we have coordinate x, y and z as a pair of variables or tuple. In this case we can apply in pattern matching using match syntax. So in different way you can apply this pattern matching. Pattern matching is quite powerful. In this first example, if you pass 0, 0, 0, so it is a complete match. Then this statement will be getting printed. If all the values will be 0, then origin will be printed. In the second example, if x and y are 0, 0, but you don't know about z, then this particular line will be executed. And here in this case we don't need to print xy because that we know it is 0 and 0. So we are printing z only. In this case we are printing, but in your real world program you can utilize the z variable data and do some of your logic. And in this third arm, these are also known as arms. And these are the matching arms if one is satisfied. If the first one is 1, and it won't compare with y and z. In our example, if you see this is the first one is 1. This line is satisfied. And we are trying to print y and z. So y and z is getting printed. And if none of this are satisfied, then if you give some random x, y, z value, the last line will be printed. For example, let's change it x to 10. Then none of the 3 conditions will be satisfied. So this line is executed, and we can see in the tuple syntax. This is our own styling syntax. You can use any way you like. So pattern matching is mostly used in conjunction with enum. So we define a color enum. Enum is a special kind of data type where whenever you define a variable of type color, so it must needs to be in this only, in this 4 type only. So you cannot create a color variable with like for example some other type like white or black or something like that. So it must needs to this format. And in this case red, green and blue, we don't have any payload, or it doesn't contain any data. But in this case of RGB, we have like it is a kind of tuple data. So all are 3 unsigned 8-bit integers. So we can have the payload as well. So here we define a variable. We could have defined color colon red as well, green, blue, but here we decided to use RGB, and we given 3 different values, and we assign it to color. This color is a type of enum, and we can apply pattern matching using match syntax. If you use match syntax, we have to provide implementation for all these 3. So you must need to provide, whenever you are using pattern matching in conjunction with enum, you must need to provide implementation for everything, or you can use underscore as well, but this is how mostly use. So if it is red, the red is printed and so on. And in case of RGB, if you have passing direct value like 000, so you are printing black. So if this exact condition will match, you are printing this. But if you are giving some other values, so this arm will be executed and RGB will be printed separately. So in case of pattern matching in conjunction with enum is bit verbose. So you have to provide implementation for everything. So for example, this one, in this case, this last line is getting printed, and these are the variables RGB. So you can use any different name for your variables, whatever is you're feeling comfortable. So this RGB value is getting printed. So this is a simple struct type point, which is to field X and Y. So we created an instance P with XY values 10 and 0. We can apply pattern matching using match keyword with the struct as well. See, here we define 2 criteria, two arms. You don't need to give this arm if you don't want to. Only if you provide this XY values, then this is fine. There is no error. But in case you want to handle this 0 and you want to process some additional logic, in that case you can provide this condition. So here you have to explicitly mention the struct type point and curly bracket XY. Here 0. This is like same syntax like this. Like this, if you passing 0, then this line will be printed. If you are passing, it doesn't match with this line, this one is printed. So in our case, it doesn't match with 0, so 10 is printed. But if you want to change it to 0, this match P will be matching, this first arm will be getting evaluated, and origin will be printed. So here we have seen different types. For example, simple variables, tuple, enum, struct, and we'll see one more example of tuple. And in conjunction with that pattern matching, you can apply some condition as well. This will become again more powerful. Like if you see in this example, here we are saying xy. Here we can take for like 2 minus 2 or 0 0 specific value also we can match. So all the thing whatever you learned in the earlier, you can apply everything there. But apart from that, you can put xy, and this is a condition you can specify. This is one important thing. If xy are equals, then this first line will be printed. If x plus y is equal to 0, in our case 2 plus minus 2 equal to 0, then this line will be printed. So this x plus y is getting 0 and 2 minus 2 is printed. If x remained at 2 divisible by it, this is like I'm divisible, or I'm not able to remember the name. So if it is 3 percentage 2, it would be remainder. This is the remainder operator. So 1, then this line would be printed. So if you see, change it to 2 plus 2, this equals to, there is equal. So x equal to y, 2, this is printed. So this is similarly, along with the pattern matching, you can apply this condition as well. So you understand the syntax. This is the same data like tuple syntax. If it is, you can apply this condition along with any other thing whatever you learn. In case of struct or variable or enum, whatever you like. So just before this is a fat arrow. There are two type of arrow being used inside Rust. One is single line arrow and one is fat arrow. Single line arrow usually used for function return type, and this fat arrow usually used for the match statement. And this is like simple single line. So each line is separated by comma to differentiate between enum. But if you have multiple line execution, you can wrap this with a curly bracket. And one more important thing, we'll define a function. See, I was talking about two different type of arrow, right? Be careful about this is the fat arrow, this is a thin arrow. This is so there is slightly different between these two arrow type. So we define a function as which returns some unsigned integer and returns some data. And not only we can apply this match along with the simple variable type, but we can apply this match with the dynamic data as well. So match age, and we can using the missing arm. So if the value is 0, print some data. If the age is between 1 and 2, we can print child and so on. So we have to give this, if you don't give this one, it will lead to error because it is not able to show that age is written what are the data. So in our case is 18, so adult will be printed. Adult. If you change it to 2, so child will be printed. This line will be executed. But at this moment, if you want to, know what are the variable you pass, like is it 1 or 2, or if it is more data, for example, if you are 20. So how we can, know that what is the data? For that, this is the variable binding syntax you can use. This syntax is slightly different. You can use @ symbol. Here you can put n. This type is a auto enforced. You don't need to explicitly mention the type. This is a variable name. Instead of n, you can use age as well, or any other variable x, y, z, whatever may be. But what do you talk about? What are the data you are passing? Even though this condition is matched, so this 2 will be set into the stored into the n. Because if you see here, we can get x and y easily here. But in this case, if you are calling a dynamic function, x is in the variable or the result type is slightly different. So n at the symbol 8, you can get this child equal to 2. Now these are the few basic concept of match. Now let's explore like if let and while let syntax. For demonstrating if let condition, now we create a variable x, and in this case x we are having an option type, and it is not a simple variable. It is not an integer type data 5, but the sum is the option type, which this x is type of option, and option contain two data. One is sum and another one is none. Sum comes with a payload. So and none comes with no data. So how it this enum is very popular. This option type of enum. This is a kind of enum, and it is why used heavily. Because there is no null pointer thing or undefined behavior inside Rust. So if the data doesn't exist, is mostly represented by option. So whenever there is a potential of any function to return some data which is not any valid payload, or there is no data present, in that case the function is calling returning none. And when there is a data, it wraps around sum. So you can't apply simple if condition to get the data. So there are different ways to do that. One of the most common is using the match statement. So this is the way you can use match x. So if x is coming sum and underscore, or you can give none as well. Because this is only having two data type. Okay. So sum none. So this x has having two possibility. If you are passing with some data, then this line will be executed. And if there is no data, this line will be executed. So this is the proper way to apply this pattern matching using enum type. But if you see this, you can directly access the x value. If you want to value access, here you can use variable shadowing concept, and you can use x as well. Sometimes some developer use it not to use many variable. But these x and y are completely different. X is the option type and y is the actually payload data. Y is represented by 5 here. If you see y is equal to 5. So y is equal to actually data. So here you can apply like you can give directly value 5, or you can apply some different concept what you learned earlier. But sometime this match syntax seems a bit verbose, so you may need a simpler syntax to utilize your logic. Now let's see that. So this if let is mostly used in case of is an alternative to pattern matching. So it looks like similar to it's traditional if else condition, but it is slightly different. So in this case you are doing pattern matching, and you can mix match with the traditional if else loop as well. Here you can use else if, but this doesn't evaluate to boolean. Whenever you use if else, it is just kind of evaluated, it will do pattern matching whether this x is having some or none. If x is having none, then this line will be printed. Or if x is having some data, then this y will contain this payload. So this if let will is a shorter version of this match syntax. At this point it looks like more or less same, but you can skip this else, it won't complain. But in case of match, you have to provide like two arms, all the arms possible. But in case of if let, you can skip the else part as well, only if you are concerned about only the some payload data. See, both are printing fine, match 5 and 5. So now let's have a little bit more with enum. This is a custom enum. Option is a already standard enum. So here we have a red, green and blue. Red contain the payload data. We define a variable color with some payload data. Now we can use the if let condition. So in this case, I am not concerned about green and blue. I don't want to provide the implementation for green and blue. So in that case, you can put a simple condition if this color is red, then execute this particular code. If color is different like green and blue, just ignore it. I don't want to do any additional logic on that. If you are using the match, you must need to provide some implementation for that as well. You are bound to. But if you are using if let, so it is also same matching, pattern matching is equal to symbol. This is not equal to, it is just simple equals. And here like similarly the value you can access using this red value. So this value will contain the payload 255 and this color is red, 255 is printed. This is much more shorter syntax than that pattern matching. Now we'll use while let. So we define a variable count. So instead of using like simple value data 0, 1, 2, that we can use anyway. But let's for example's sake, we have wrap this with a option sum. And this mutable data we put like because in the loop we want to increment or increment this count value. So in this case, while let, this is a kind of this is a pattern matching expression. It's not a simple condition. In other while traditional while loop, this particular thing is a boolean value, but this is not a boolean value. This is simple kind of comparison pattern matching. It is talking about if count is of some, it contains again count is option type. Option can contain some or none. If it is none, then don't execute this loop or exit this loop. Go out of this loop. But if the count contains some value with any payload, then execute this under this whatever the code is going to write under this curly bracket. You have to execute. So if it is none, exit the loop. If there is a payload with option data, you have to execute it. And the value whatever stored in the option is represented by I. In the first iteration, I would be 0. So here inside that, if you put a simple if else condition, if I is greater than 10, count we assign to none. But if I equal to 0 in the first iteration, we print this I. And we are because it is a mutable thing, we create a new instance of sum. This is a new we are assigning again because this is mutable. We can do that. Because we access I value, first iteration is 0, 0 plus 1. Here we can't assign like count plus count. We can't do that effectively. So we have to create another instance sum, and we have to extract this I plus 1. So if I is greater than 10, then count we assign to none. This condition will be not satisfied. After that, it will break. So in this way, we can use while let also. But while let is not very commonly used. But the most commonly used is the if let in many scenarios. So today we discuss about pattern matching, if let and while let. And before I wrap for today's videos, I'd like to give a big thanks to Rust by Example book. Most of the examples are derived or adapted from this particular book. So I highly recommend go through these books. There are plenty of examples and I will cover most of this example in my video tutorial. Thanks for watching. Have a good day ahead. Bye bye.